Power on a steel MS 661 shows how a heavy gray poplar can be handled with controlled force. The saw, with its 71 cm Roll-O-Matic ES light bar, engages the 150 cm trunk, and chips start moving in steady streams. The torque holds steady even when the fibers tighten around the bar. The first cut opens space for guiding the next pass, and operators adjust stance and angle to keep the kerf clear. The chain tracks smoothly under load. Bark thickness influences each move, and small shifts in grain direction change how the saw pulls. Bar temperature rises fast on wide bites. A quick plunge helps manage binding, and the poplar responds with predictable resistance. Chain speed stays consistent across the full bar length. A wedge adds separation before the main drive cut. Kickback zones stay under control. When the trunk settles, the final release drops cleanly. Unexpected. A wide cypress stump stands before the saw, setting up a forceful takedown. The saw carves a controlled face cut, and chips fly across the bark. That spray looks like the stump giving up its grip. The back cut follows, and wedges secure the fall direction. The drop hits harder than expected. The trunk settles, and the crew sections it into rounds, each slice landing with a confidence boost, wrapping the job cleanly. Large oak sections often call for a machine that can stay firm under wide cuts, and the Serra Africa SL 160 fits that scale with its long horizontal band mill layout. The blade tracks across a 1.4-meter oak trunk, and each forward move builds a clean path for the next. The stability here keeps the cut on line even when the oak grain tightens. Operators position the log on the bed, blocking support points to avoid shifting under the blade's sweep. The frame barely moves despite the log size. Guiding the first pass sets reference surfaces, and the long band glides through the trunk with steady tension. Blade speed holds consistent across the full travel. Sawdust streams out in thick curls, and the oak responds with dense resistance. A sideways glance at that huge trunk almost feels comic, like the log underestimated how long the band is. Successive passes flatten opposing sides, giving the mill a stable base for deeper cuts. The cut width stays predictable across the entire slab. Sawyers monitor feed rate to prevent binding, and minor adjustments in log angle help maintain flow. The Africa SL 160 manages these wide faces without hesitation. Unexpected hit of respect there. Once the slab is freed, the remainder of the trunk is rotated for additional sheets, maintaining alignment until the stack is complete. The combination of long bed support and horizontal drive keeps each oak piece uniform and production ready. Water pressure pushes across each log at pose and project, giving the bark no chance to cling. The stream tracks along knots and curves until clean wood shows through. Hard to believe how quickly the wood looks ready for construction, and some logs look like they had a spa a day after this wash. The micromill tackles each log with exacting care, producing precise cuts for a blockhouse assembly. Operators guide the machine along the pre-marked lines, ensuring every joint aligns perfectly. Accuracy at this level prevents misfits during construction. Logs are stabilized and held firmly, while the micromill's blade carves clean edges without splintering. Even complex angles are handled with apparent ease. After the initial cut, measurements are double-checked to guarantee uniformity across multiple logs. Chamfers and interlocking notches are completed sequentially, ensuring snug assembly of the blockhouse. Small adjustments now save hours during the final build. Tool wear is monitored carefully to maintain cutting quality. One can appreciate the seamless blend of machinery and human oversight here. Operators frequently rotate logs and reposition clamps, verifying every dimension matches the design. Nothing beats a corner cut that fits without forcing. The micromill's consistency allows builders to focus on assembly speed without compromising structural integrity. A bit funny to see logs practically line up themselves under such precise guidance. By the end, each log is ready for installation, with all cuts meeting strict tolerance standards. The outcome is a blockhouse that can be assembled efficiently, safely, and accurately. Watch each log settle into place, guided by expert hands adjusting angles and notches. The crew positions Karelian pine logs with careful attention, forming the foundation of a traditional Russian cup-notch log house. Each log's natural grain and moisture requires precise handling to ensure snug alignment. Marking lines for the cup notch is the next step, using traditional measuring tools to outline where cuts will occur. Every mark made on the wood shows the experience embedded in this craft. The marks guide the saws, ensuring each notch aligns perfectly with its counterpart. Hand saws carefully follow the marked lines, cutting each notch with steady control. Logs are cut to form the notches, gradually shaping each corner for a tight fit. The crew occasionally double-checks lines mid-cut to maintain flawless alignment. Each pass of the saw removes material exactly where it's needed, producing a clean groove ready for assembly. That cut goes deeper than expected, and you can almost feel the tension in the timber as it gives way. Logs are smoothed along the cut edges, removing minor splinters and preparing them for final assembly. Each piece now fits like it was made for this exact position. Even small variations in the log shape are corrected immediately for perfect alignment. The method highlights the blend of traditional technique and skilled hands, producing robust, long-lasting walls while preserving the wood's natural character. This careful process proves that simple tools and human judgment can accomplish what machines alone cannot. Once the cuts are complete, the team checks the fit between logs, adjusting positions gently until each notch sits flush. Logs slide slightly into place thanks to natural moisture, and minor adjustments ensure walls will be level without forcing the wood. Even small touches here make the difference between a simple stack and a durable structure. The log rests on the cutting area, prepared for a precise corner notch cut, commonly called lap joint. The saw carefully follows the marked lines, ensuring each angle meets structural requirements. The accuracy here guarantees perfect assembly later. Wood fibers respond to the blade as small chips fly off. Even short logs demand respect from the operator. After the first cut, angles are double-checked, and adjustments are made for clean fit. Simple actions, big impact on joinery quality. One might chuckle at how much focus a single corner takes. Wood from Siberia forms the heart of a new cabin destined for German clients. Every log is carefully prepared to ensure stability and longevity. The project blends two construction methods. One section uses a frame structure, while another employs traditional log-on log building, known as the Canadian method. Logs are numbered and marked for precise assembly. The logs range from 46 to 50 centimeters in diameter and are kiln-dried for optimal moisture control. Kiln drying prevents unexpected shrinkage and warping during transport. Each log is cut with saddle notches at corners, designed to settle as walls shrink and compress insulation naturally. This ensures a snug fit without gaps over time. On the kitchen wall, logs are flattened to accommodate furniture installation. A hidden lighting concept threads through the branch-like structures in the central living area, aiming to create diffused light descending from the ceiling. The main hall is envisioned as a social space, combining fireplace comfort with openness up to the roof. Wooden laminated panels, up to 3 meters wide and 12 meters long, are integrated into the design, with quartered edges for exact fitting. Each panel is carefully marked and prepared before disassembly for shipping. Once disassembled, all elements are loaded into trucks bound for Germany. This modular preparation ensures efficient transport and reassembly overseas. House crews will follow detailed instructions to reconstruct the cabin. The combination of traditional log techniques and modern planning ensures a durable, aesthetic home. The balance between settling logs and fixed frame structures keeps the building aligned as intended. Even with complex assembly, the workflow shows remarkable coordination. It's like the cabin knows its final shape. Panels spanning several meters are stacked and pressed precisely on the X-press system. Loose strips are aligned precisely, forming single longitudinal and cross layers that will interlock into solid panels. Each layer is checked to ensure the glue lines and orientation match the design specifications. Prefabricated cross layers are sometimes used, positioned carefully on a separate press before combining with freshly glued longitudinal strips. The press applies uniform pressure, bonding the layers into a single, stable panel. Handlers monitor the alignment continuously, preventing any displacement during pressing. The stacked elements hold together firmly under consistent pressure, creating a flawless bond. Once pressed, the CLT panels are released and inspected. Minor adjustments are made if necessary to maintain straightness and edge quality. Smoothing and trimming ensure that each panel meets exact tolerances, ready for wall assembly. The result reflects both engineered precision and human oversight. The method allows for combining pre-glued layers with fresh glue in a hybrid stack, optimizing strength and efficiency. Throughout the process, operators coordinate movement of layers, aligning them for optimal adhesion and minimal gaps. The combination of mechanical pressing and careful manual handling ensures durable, high-quality CLT panels suitable for modern construction. That stack moves like it knows exactly where to sit. The hybrid layering feels like a wood puzzle coming together. This setup shows how a specialized press can handle complex, layered assemblies while keeping production smooth. A crisp November morning sets the stage, as Wild Rose Timberworks brings their team to the Decorah Fish Hatchery on Trout Run Road. Raising a timber frame is an exercise in harmony, where skill, timing, and understanding of wood intersect. Each timber carries unique characteristics, from knots to subtle curvature, requiring the crew to adapt as they lift and position each element. Main posts are erected first, secured with temporary braces, while verticality is verified. Observing the frame take shape highlights how every piece interlocks through traditional joinery, combining both durability and elegance. The sight of these massive timbers moving as a cohesive unit almost feels like witnessing a living structure assemble itself. Cross beams are then hoisted into place. Slings and chains guide the heavy timbers, while crew members ensure that each piece meets its intended notch precisely. Every lift is a choreography of hands and ropes, a quiet coordination that feels satisfying to watch. The wood responds predictably to guidance, showing the strength and flexibility inherent in well-seasoned timber. Measurements are checked repeatedly. Levels and squares confirm corners and plumb posts. That tiny adjustment at a corner can make all the difference for alignment later. This stage underscores the combination of human judgment, experience, and the physicality required for large timber assembly. Next, mortise-and-tenon joints are carefully fitted. Beams are lowered so tenons slide smoothly into their corresponding mortises. Precision in this step feels like a dialogue between the wood and the hands guiding it. Temporary wedges keep spacing consistent while other beams are lifted into position. Even the most experienced members pause, verifying fit and alignment before final pegging. That pause shows respect for the material and the craft itself. Wooden pegs are inserted, locking the structure without metal fasteners. Hitting each peg feels oddly rewarding, like the frame whispers that it's secure. The tactile engagement of driving pegs provides immediate feedback, confirming structural integrity. You can almost feel the timber settle as each joint becomes permanent. As additional beams are added, the frame gains rigidity. Lifts often require coordination between 2 or 3 crew members. It's incredible how multiple people can move something so heavy with synchrony. Diagonal bracing is installed to prevent sway, with temporary supports remaining until the roof skeleton is completed. Each peg hammered transmits a subtle pulse through the frame, reinforcing the sense that every joint is correctly seated. Even the smallest movement is considered before any peg is driven. Roof beams, longer than most previous pieces, are lifted into place with winches, pulleys, and synchronized manual effort. Some beams seem to float gracefully under the team's guidance, aligning perfectly with pre-marked notches. Each rafter placement is checked for proper spacing to allow future roofing materials. That moment when a beam drops exactly into its notch sparks a quiet cheer. Seeing a complete roof framework held together by nothing but joinery and pegs is both impressive and reassuring. The balance of weight and skill here is mesmerizing, even if no one says it aloud. Secondary supports and smaller braces are installed next, preventing lateral movement and supporting the roof weight during construction. That careful layering of timbers exemplifies why timber frame structures endure for centuries. Alignment, verticality, and joint tightness are rechecked constantly. Minor gaps are adjusted using wedges, ensuring structural integrity and longevity. Each adjustment highlights how small corrections can have major impacts on the final stability of the structure. By the end of the day, the timber skeleton stands complete. Open yet defined, it awaits exterior cladding, roofing, and interior finishes. Looking up the frame gives a rush of accomplishment for everyone involved. It's striking how massive timbers can appear almost effortless once aligned perfectly, thanks to a combination of experience, planning, and traditional techniques. Temporary braces remain in place to prevent movement until the roof and finishing components are applied. The team's rhythm, coordination, and attention to wood behavior reflect both skill and respect for the material. Every motion is intentional, contributing to a frame that will endure decades. Every motion is intentional, contributing to a frame that can withstand seasonal changes in Iowa. Teamwork and safety remain essential throughout. Crew members communicate constantly, guiding timbers into place while monitoring for hazards. It's surprising how much thought goes into every hand placement. That level of situational awareness allows complex lifts to occur smoothly without rushing or error. Hand tools, levels, mallets, measuring tapes, and wooden pegs accomplish every necessary task. Watching 2 or 3 people coordinate on a single lift feels like a puzzle falling perfectly into place. Sometimes it's entertaining to see how a small shift in one timber can require subtle adjustments from multiple hands simultaneously. Physical effort is carefully balanced with timing and technique. Even the tiniest misalignment is immediately corrected before it compounds. Community involvement made this project possible. Friends of the Fish Hatchery raised funds through private donations and grants, ensuring materials, labor, and logistics were all covered. Knowing the community contributed gives the project an added sense of purpose. This support allowed construction of a shelter that will serve visitors with restrooms and interpretive spaces while blending seamlessly with the hatchery environment. The building almost feels like a gift to both people and nature. It's satisfying to observe a project that is both practical and harmonious with nature. Even after the main frame is raised, crews inspect every joint, adjusting pegs and braces where necessary. Repeated inspection prevents small errors from becoming problems. These small corrections accumulate to a substantial improvement in stability and structural integrity. Diagonal supports are finalized, and minor shifts in beams ensure the frame is ready for roofing. That moment when all the beams align perfectly is almost electric. That satisfying moment when every component sits flush reminds the team of the importance of patience and skill. By the end, all timbers interlock perfectly, reflecting centuries-old craftsmanship adapted for a modern, public-use building. It's a tangible lesson in tradition and care. The process highlights several principles of timber construction: attention to joint fit, coordination of heavy elements, and understanding wood behavior. Even casual observers can appreciate the deliberate care embedded in each beam's placement. Every beam is handled with a level of respect that shows why timber frames last generations. Each timber is handled purposefully from initial lift to final pegging. It's remarkable how traditional joinery, executed skillfully, eliminates the need for nails or screws. Braces and pegs alone maintain an incredible level of stability. Temporary braces maintain stability, allowing safe installation of roof and finishing elements. There's a quiet thrill in seeing the frame resist all movement once pegged. Every action is methodical, reinforcing the reliability of a timber frame that can last generations. Finally, the timber frame stands as a testament to both traditional craft and modern teamwork. Seeing each post, beam, and brace secured gives a tangible sense of achievement and durability. The frame almost tells the story of the people who built it. The structure is functional, durable, and visually integrated into its surroundings. Even brief observation conveys the thought, planning, and effort embedded in the assembly of each timber. It's unexpectedly rewarding to stand back and see how everything fits together. The project demonstrates how careful planning, skill, and respect for the material can create a building that is educational, functional, and faithful to traditional methods. That final glance up the completed frame makes all coordination and effort tangible and rewarding. The building stands as proof that patience, skill, and teamwork really matter. Shingles, made from carefully selected timber, are stacked and prepared for shaping in the workshop. Each piece carries its own grain and moisture profile, influencing how it will split and taper. The craftsmen use a specialized tool to peel the bark from each timber. The bark separator carefully lifts the outer layer without damaging the wood beneath. Operators position the tool along the grain, applying steady pressure to remove bark in long, even strips. Each plank responds differently, depending on moisture and density, requiring subtle adjustment. This step exposes the clean wood surface, preparing it for accurate marking and cutting of shingles. Stripped timber is immediately inspected for hidden knots or imperfections that could affect splitting. The team checks each plank, ensuring it meets size and quality expectations before cutting. Handling wood this way shows the importance of understanding natural material properties. Operators align the timber for splitting, guided by visual markers and experience. Marks are drawn along the boards to indicate where the shingles will be formed. Each marking is double-checked to prevent errors during cutting. Each line tells a story of the craftsmanship involved, marking the points for controlled cuts. Saws follow these lines, both hand and light mechanical types, producing grooves that guide the splitting process. The operator glances along the edge, confirming alignment before the saw moves. This precision ensures that every shingle will fit perfectly in its intended roofing arrangement. The next step involves splitting along the scored lines. Controlled pressure opens the wood along its natural grain. Logs that resist splitting are repositioned for a cleaner break. Pieces that resist splitting are carefully repositioned. The process continues methodically, producing shingles of consistent thickness and taper. Each cut is monitored to maintain uniformity across the batch. Even subtle variations in grain are accounted for, allowing each shingle to maintain structural integrity and a uniform appearance. Once split, the edges are smoothed, removing roughness or small splinters. Craftsmen inspect the taper and width, trimming where necessary to achieve exact dimensions. Small adjustments are made to keep each shingle consistent with its neighbors. Stacks are labeled according to size and quality, ready for drying or further finishing. Observing the panels gradually shrink to their final shape reveals the careful balance of moisture management and handling. Panels are spaced to ensure airflow reaches every layer. Shingles are then arranged in drying racks or kilns, spaced to ensure even airflow and moisture release. Temperature and humidity are monitored to prevent warping or cracking. Staff record drying conditions for each batch to maintain traceability. This stage demonstrates how proper drying enhances the durability and performance of each shingle. After drying, the shingles are sorted again, inspecting for any defects or inconsistencies. Only those meeting strict standards move forward to packaging and distribution. Throughout the production, teamwork and attention to detail are key. Operators coordinate their actions, passing pieces efficiently while monitoring for quality. Even minor deviations in angle or cut can affect the final product, so constant vigilance is required. A quick visual check ensures no misaligned shingles proceed to the next stage. The rhythm of work combines human skill with tool accuracy, producing a consistent, reliable outcome. This traditional German method balances handcraft and mechanical assistance, producing shingles that are strong, durable, and visually consistent. Each panel demonstrates how centuries-old techniques can integrate with modern tools to maintain quality at scale. The team observes how boards react differently depending on grain orientation. The workflow shows a blend of control, patience, and understanding of timber behavior. Some stacks seem to almost fold themselves perfectly into drying racks, moving like pieces in a carefully managed puzzle. Inspecting finished shingles, operators check the straightness, taper, and uniformity. These final checks ensure the shingles will fit neatly on rooftops, providing effective weather protection and aesthetic consistency. Any minor imperfections are corrected or removed, maintaining overall quality. A final tactile check confirms smooth edges on each shingle. The finished product represents a sequence of deliberate, controlled steps that turn raw timber into functional building materials. Even as tools guide the cuts, the human eye ensures consistency. Adjustments are made in real time, balancing speed with accuracy. The process highlights how skillful observation complements mechanical assistance, producing shingles that meet strict dimensional and performance criteria. The drying racks themselves are an integral part of the method, designed to encourage uniform moisture release and prevent warping. During final inspection, batches are graded for thickness, length, and split quality. Pieces that fail to meet these standards are set aside for recycling or alternative use. This stage shows the importance of rigorous quality control in maintaining the integrity of traditional shingles. Once approved, shingles are bundled and prepared for shipment. Bundles are labeled for size and drying conditions before leaving the workshop. Throughout the facility, the blend of craftsmanship, mechanical tools, and careful observation produces shingles that are both durable and visually appealing. The workflow demonstrates how human skill and simple machines interact to maintain a balance of efficiency and quality. Every step, from initial scoring to final drying, contributes to the structural and aesthetic performance of the shingles. These shingles are then ready to be integrated into roofs, providing a protective, long-lasting layer. Contractors appreciate the precision and uniformity achieved through this process. The production emphasizes that even with modern aids, understanding the natural behavior of timber remains crucial. Careful handling ensures that the natural variations in each board are managed effectively, producing a product that is reliable in service and consistent in appearance. Overall, the method illustrates a seamless combination of traditional knowledge and practical mechanical assistance. Every shingle is a product of controlled cutting, splitting, and drying that respects the material's properties. The balance of speed, accuracy, and quality control throughout the facility guarantees a finished product suitable for demanding applications. Even casual observers can sense the thought and planning that went into each batch of shingles. The result is a steady stream of shingles, uniform in shape and thickness, ready to meet modern construction demands. The integration of light machinery with skilled hands ensures that production is both efficient and reliable. Watching the boards split along their natural grain, it's clear that each shingle has been guided with care and attention at every stage. The workflow allows a steady output while keeping defects to a minimum, reflecting the precision of German woodworking traditions. Shingle bundles are then sorted and packaged for shipment. Correct labeling and stacking ensure safe transport to construction sites. The combination of human oversight, proper handling, and mechanical assistance ensures that each bundle maintains the integrity of its contents. The production line highlights how methodical, consistent procedures yield high-quality timber products. Finally, the finished shingles are ready for installation, offering a combination of durability, visual appeal, and functional performance. The workflow, from raw timber to finished product, demonstrates how traditional methods and modern aids can coexist effectively. The care at every stage ensures that each roof will benefit from well-made, long-lasting shingles. Some batches seem almost eager to stack neatly, ready to take their place in a roof. That split feels smoother than expected, moving like it was meant to be. Even small details in each bundle reflect hours of concentrated effort,